Innovation is the only sustainable form of differentiation. Hi, welcome to another series of innovation news updates from nttcomdd. My name is Hui-Yung Seong. In this demo, we will create an Internet of Things IoT server on Raspberry Pi server. This will allow us to collect all kinds of sensor data, send it over the network to this Raspberry Pi server, and visualize it on a Grafana dashboard. In our setup, we have a temperature and humidity sensor connected to Raspberry Pi computer acting as sensor node. It collects data every second. The data is wrapped into a JSON message and is sent over to the IoT server via MQTT message protocol. MQTT protocol is basically where a client publishes data to a broker or a server, such as Mosquito, which is the application being used in this IoT server. The broker pushes the data that has been sent to it to any client that has subscribed. In our IoT server, an application called Node-RED will be the subscriber and interpret the JSON message data and then send the data to a database to be stored and eventually used. In this case, we are going to use InfluxDB to store the sensor data, and then we are going to use Grafana front end, which is going to query the database in order to display the data we want to see in a nice format. We are going to run these applications within containers using Docker. Running an application inside a container means it's really quick to set up and deploy. Now let's start to set up the IoT server for our demo scenario. The first step is to download IoT Stack using this curl command. This will also install Docker, Docker Compose, and other necessary packages. Once it's done, enter the IoT Stack folder. Open the menu with the menu.h. Use Enter to select Build Stack. This is where we can select the packages that we want to use. We can navigate using the up and down arrow keys and spacebar to select. We are going to select Grafana, InfluxDB, Mosquito, and Node-RED. When we select Node-RED, we might see a warning. Press the right arrow key to enter the options list, and the defaults are fine. Press Enter to build this list and then navigate to return to the menu. Continue to select the rest like Portainer, which is going to give us a graphical interface to manage these Docker containers. Once all of these components have been selected, we can press Enter again, and that's going to build a file which essentially contains all the different components we have set and how to configure them. Next, navigate to the Docker command section and select Start Stack, and this will start all of these containers. Once it's done, all applications should now be running, and we can test this with Docker Compose PS command. It should show you 5 containers. Another way to look at this is to open Portainer by opening a web browser, navigating to the IP address of the IoT server, and use the port 9000. Let's log into the Portainer, click on the option to see the local Docker containers, and then we can click on the containers to see a list of them. This gives us a graphical interface way to interact with these containers, so we can open things like a console in them or turn them off. Now let's start configuring our applications. First, we are going to create an InfluxDB database in order to store all our sensor data. Let's go back to our terminal and use the command docker exec, it influxdb influx. What this is going to do is to enter the command prompt that we are using into Docker containers so that the commands that we run are executed inside that container. We use the command create database and then the name of the database we want to make say sensor data and then hit enter. It will create the database and we can then exit using quit. Next, we are going to configure Node-RED. Navigate to the server via a web browser by entering its IP address and the port 1880. This is a visual sort of programming where we can build a workflow by dragging and dropping boxes from the left-hand panel and linking them up. We are going to need 3 units, which are the MQTT input, change node, and InfluxDB output. Let's link them up. Now to configure the inputs, double-click on the MQTT input button, and we need to add a server by clicking on the pencil. We can name the server, say MQTT Docker, and type the name or IP address of the IOT server into the server address box. Leave the port as default 1883, press Add Server, and then select the server from the drop-down list. We can then type the topic of the data that we want to subscribe to, which is home sensors, and we want a parsed JSON object from this block. For the name, we will enter the same as topic name, which is home sensors. In the change block, we want to change the transmitted message into a JSON expression, and we select the JSON expression from the list and press the button with the 3 dots. In this expression, we are going to change the keys in the original message to something a little bit more descriptive. Temperature message.payload_t and then followed by humidity message.payload.h. Save and close this window. Last but not least, we have to configure the output node. Double-click this and then press the pencil next to the server and change the host to Raspberry Pi and use the port 8086. Then we use the database name that we previously created, which is sensor data. Press Add, and then we need to name the measurement we are writing the data to, say sensor data. Close this panel and hit Deploy to save and implement this configuration. Now we need to make sure our sensor node is transmitting data. So let's switch to the terminal of the sensor node and trigger the node to start the transmission. So you can see that the sensor now is collecting the temperature and humidity data and then send it over to the IoT server via MQTT protocol. Now we can test if the node-RED configuration has worked by checking that there are some entries in the table. We head back to the terminal and enter the InfluxDB container again. We can enter the command use sensor data and then show measurements and then select from sensor data. Then you should see some data being populated. This means that we are ready to set up our graphical interface. Open up the Grafana dashboard via a web browser, which is the IoT server hostname with the port 3000. It might prompt you for some credentials and ask to change the password. The first thing we need to do is to add a data source. Select InfluxDB and then enter the URL of our IoT server with its port number, which is Raspberry Pi 8086. Scroll down and then enter the database name, sensor data, and then the get HTTP method. Click Save and Test. We should see a green bar saying that the data source is configured and confirmed. Next, we can create dashboard where we will see all the information we have recorded. Select Create New Dashboard and then add a panel in the Measurements box. In the From part of the data source, select Sensor Data and then under the Field option, pick the variable to be plotted. For example, temperature. Now we can see some data being populated in the graph. We can name the panel on the right-hand side as temperature and click Apply. Repeat this process for humidity field, so measurement, sensor data, humidity as a field, and save this panel. Once we are happy with our dashboard, let's save the dashboard, so we'll call it Sensor Dashboard and change the time range, let's say 30 minutes. That's it. We have created a nice IoT server on the Raspberry Pi, which will take the sensor data sent from nodes using MQTT protocol, and it will be plotted in a nice graphical dashboard. Thank you, and we shall see you on our next episode of nttcomdd Innovation News Update.